Welcome to this video presentation on discrete signals. In this presentation we're not really covering any new theory. We're basically just going to use MATLAB, which is a tool that we can use to manipulate and visualize discrete signals. Now the purpose of this demonstration isn't a tutorial in MATLAB. There's quite a bit to MATLAB and I've links to various tutorials on the series website. So you should take a look at that, but you do need to become comfortable with MATLAB in order to progress through the series. The real purpose of this demonstration is just to give you an idea about how MATLAB can be used to manipulate signals, and you'll see that there are a number of commands in MATLAB which allows you to visualize and manipulate signals very quickly. So it's really just to give you a flavor. Please see the other tutorials to get a good handle on MATLAB. Well, first of all, let's create a very basic signal in MATLAB, and we'll use a signal we've seen earlier on. So square brackets, 0.5, that's my first sample in my discrete signal. 9, 2.5, 7.3, 4, and 6. So that's my discrete signal. Now, I'm going to highlight this point early on anyway. There is an issue with MATLAB, the notation, mainly the notation that MATLAB uses versus the mathematical notation. If this is our discrete signal here, MATLAB will refer to the first element as x bracket 1, whereas mathematically the first element would be referred to as x square bracket 0. The second element there would be referred to as x square bracket 1. The third one here would be referred to as x square bracket 2, and so on. So MATLAB is slightly different. You'll see that it refers to the first element as x rounded bracket 1. So I'll just switch back to MATLAB now. So the first element, x rounded bracket 1. The next one would be x rounded bracket 2, etc. Now this does cause a bit of confusion for people starting out with MATLAB, so just be aware of it. Once you get used to it, you can overcome the problems quite quickly, but you need to be used to both forms of notation. You need the mathematical notation in order to review a lot of the textbooks in the area, but you'll need to get used to this notation because ultimately when you want to start manipulate signals and apply some algorithms to signals, you will do so in MATLAB and you need to get used to the notation used. But we'll move on. One of the most powerful things in MATLAB is to be able to quickly visualize a signal. So I'm going to make use of the plot function. So if I type plot x, and I'm going to specify to plot it in red by typing the character or there in quotes, and 0 to plot individual samples. So there is my discrete signal x, and as you can see in the plot, the first sample is referred to as number 1, the second sample is referred to as number 2. That'll be different mathematically, of course. So that's the plot of the signal. Now again, that can be difficult to interpret. So oftentimes we would get MATLAB to interpolate between the samples, and that can be done very quickly. So I'm going to type hold on here, which allows me to plot twice to the same figure. So I'll still see my red zeros, but I'm also just going to plot x now, and when I just type plot x, I get this blue line which shows each sample connected. And I generally find that a much easier way to visualize the signal as opposed to just plotting the individual samples. But again, the discrete signal is just each individual sample. It's not really the blue line between each sample, and it's an important point to make because discrete signals only exist at discrete points along the axis, the x-axis. Now let's go back to MATLAB, the command window of MATLAB, and that's a very basic signal. What I'd like to show you now is quickly how we can manipulate a real world signal. So what I'm going to do now is load in a recording of drum sounds that I've stored in a WAV file. So to do that, to load in the file, I say WAV read and I specify the location of the signal. So it's in my test sigs folder, a file called drum sounds.wav. Okay, so a WAV file is kind of like an MP3. An MP3 is a compressed audio file, whereas a WAV file is an uncompressed audio file. And basically X is a discrete signal that represents the sound file. Now, like all discrete signals, it's just simply a sequence of numbers. So what you're seeing here, and I'll do it again, is a sequence of numbers that represent X. Now there's lots of them there. We're only seeing a few flicking up on the screen, but there are actually, I can determine exactly how many by typing the length of X. That'll tell me how many samples are in the variable X. So there's 289,734 samples. Now what does that mean? Well, the first thing is I know that that recording was sampled at 44,100 samples every second. So every second of audio contains 44,100 samples. So if I divide the total number of samples by 44,100, I'll see the duration of the audio file. So that's roughly 6.56, well, exactly 6.5699 seconds of audio. So I can play that back using a sound command in MATLAB. Now when I play it back, I have to specify the sampling rate. So let's hit play and hear what that sounds like. So in that recording, you should have heard a number of drum sounds. Now we'll just plot that data as well. So we've interpreted through a sound. Now let's interpret it visually. So we'll just plot X. I'm not going to plot the individual samples, I'm just going to plot the connected samples. And I'll just turn off hold off first before I do that. Plot X. So that is a visualization of the discrete sequence of numbers. So we see along this axis here, so the x-axis, that is my sample number. So if I look along here, I see that I have 3 by 10 to the power of 5, which is 100,000, so 300,000 samples roughly. And we saw exactly how many there were a second ago. Now along the amplitude axis, you can see there's bursts of energy. Now each one of those bursts of energy represents the instant at which the drumstick hit the drum. So we can count here, we have 1, 2, 3, 4, 5 drum beats. So this is our first bit of discrete signal analysis. We're analysing the signal and we're seeing that there are 5 drum beats. Now if we look at the plot, we can see some other bits of information. So I can see that the last drum sound has a rather long, what I would call decay. So the last drum sound was a cymbal, and that cymbal takes a while to decay, so there's a ringing associated with the cymbal. Whereas the second last one, I think, was a tom, and that's got a very short decay. So when you listen to the sound again, just keep an eye out for that type of thing. But we should hear 5 drum sounds, and the last drum sound is a long decay. So we'll just switch back to MATLAB and we'll listen to the sound again. So that cymbal there has a very long decay over time. So what we're doing there is we're doing a bit of signal analysis by looking at the plot and seeing the content of the discrete signal. We're doing some analysis. Okay, now the beauty of discrete signals are that they are just sequences of numbers. And once we have a signal as a sequence of numbers, we can easily start to manipulate it. If we switch back to the plot again, just plot x, and we take a look at it, we can see that there are regions here where we just low values. Now each of these, so this region around here is a region of silence. So what I'd like to do is maybe replace one of these drum sounds. I might actually replace two of them. I'll replace two of these drum sounds with silence. So by zooming in here, so I've zoomed in on the two drum sounds that I might remove, and I can see that the first drum sound starts around 3.5 by 10 to the power 4, so that's 35,000 samples into the signal. Our first drum sound occurs, and the second one ends around 75,000 samples. So what I can do with this signal is manipulate it. First of all, I'm going to make a copy of the original by saying x1 equals x. So x1 is now my original signal. And what I'm going to do here is manipulate the signal. Don't worry about what I'm typing too much, I'll just quickly run through it. And you will get used to this over time. But what I've done here is I've specified a range of values. So the variable x, from 35,000 samples up to 75,000 samples, I'm going to set equal to 0. And by doing that, I should set that range, all those samples will become 0. So I'll just do that now. And I will plot my original signal. And I'm going to, so I plotted x1. I'm going to hold on and now plot the new signal, modified signal, over it. And we should see, as we do, two of the drum beats have been removed. So the red represents my modified signal. And in this first part, the first drum beat is still there, so the red and the blue overlap exactly. But you can see the original, the blue parts here are the two drum beats that have been removed. So they've been removed from the red but are still there in the blue signal, which is my original. So if we switch back to MATLAB, and we can play back each of those sounds. So let's play the original first. Well, I've very easily manipulated x, so I'll put in more silence. So you could hear in that second example, the variable x has the two of the drum beats removed. Okay, so the idea of this presentation was just to give you some idea about how you can start to manipulate these signals. To do so effectively, you will really need to get used to MATLAB. So I recommend you go through all the tutorials that are up on the series website and start to manipulate those sounds and signals. Because the only way to get used to MATLAB is to actually use it. You can't just watch demonstrations all the time. Okay, look forward to seeing you in the next presentation.